Howdy, we're the Los Alamos National Laboratory team. My name's Nathan Stern, and I'm the team CEO. I was in charge of managing the team and managing the software development cycle from beginning to end, and also maintaining communication with our client to make sure that, yeah, we were meeting all their deliverables and all their needs.
Howdy, my name is Taylor, and as the Chief Technology Officer, my main job was to make sure that all new updates and all new features were incorporated and tested properly throughout all the different stages of development.
Howdy, my name is Alice, and I'm the Chief Design Officer, and I was in charge of creating the design and communicating with our client to ensure that the experience matched with their expectations.
Yeah. So like I said earlier, we worked with Los Alamos National Laboratory, and specifically we worked with the M9 team. And what this team did is they perform experiments on metals and polymers to kind of see how they behave under certain conditions. And they use gas and powder guns, but the instrument that we're focusing on is the oscilloscope. So they use oscilloscopes to take measurements and be able to take waveform data and time and voltage data for these experiments. But the problem currently is that when setting up these oscilloscopes and when using them, it's a lot of manual configuration. They have to push a lot of buttons. They have to do it one by one, and it's very tedious. In addition, the software that they use is in LabVIEW. It's very slow, it's buggy, it's memory intensive, and ultimately it's just not a good experience at all for the users. So our solution was we created a simple user interface in Python that just is easier to use. It's more simple, it's faster, it's less buggy, and it actually works with the old scopes and with future scopes as well. In addition, we have a lot of automation, so it can automatically load configurations, it can automatically arm the devices, and it can automatically save data straight to the laptop. Um, yeah, all with the push of a button. And what's even cooler is that for all the different scopes that are connected all at the same time, our user interface acts as a unified hub that allows them to arm all the devices connected at the same time, save the data from all the devices at the same time, and just interact with all the scopes at the same time straight from one user interface.
Yeah, and I'll go over some of the technologies we used to develop this. So at the start, our main goal was to be able to create something that Los Alamos can actually use with their devices, and for this to be able to be passed on to future capstone teams. So starting off, we actually reached out to Los Alamos in the beginning, and we asked them to send over some of their hardware in order to make sure that we could actually create software that worked with their actual devices that they use on day-to-day experiments. So these are Tektronix oscilloscopes that they sent over to us. And as for the software side, we decided to use Python. And the biggest benefit to using Python is there are so many open source libraries that we could use to our benefit. And some of those are listed here, such as PyVisa. So PyVisa is the main one we use to connect and do all our communication with the oscilloscopes. It's able to send Skippy commands and tell it to either arm, trigger, or retrieve data. Next, we have PyQt. And PyQt, initially, we were searching for something that we were familiar with because in the classroom, we're used to using HTML, CSS for front-end development. And we actually found that PyQt, the styling for it is near identical to CSS. So that's the main reason we picked that one. And we think that future teams will be able to pick it up even easier. Then we have NumPy, and NumPy is used to format all of our data collection just the way that Lena wants it and that they're used to seeing. And the sort of workflow that the experiments are is you plug in the device using USB or Ethernet. Then once it propagates into the table, you're able to load in the settings, select it for an experiment. Then the devices can be armed. Once the devices are armed, then the oscilloscopes are searching for data. Once data is found, then it's set into the triggered stage. After the oscilloscope has been triggered, the interface lets you know that you can save the data off of all the oscilloscopes that are connected for the experiment, and then you can select the data format to save as. And then for some core features, of course, we have the user-friendly interface. After weeks and weeks of communication with our sponsor, we were able to design the user interface that we have today. That's all in one page. It's easy, it's modern, and it's easy to navigate. Next, we have the device connection. So as soon as you manually plug in via USB or Ethernet, the devices propagate to our table automatically and show in the table and show their name, whether you unplug it or plug it back in. And speaking on the names, the first time you plug it in, it actually shows the visa address of the devices, which is not very user-friendly. So we actually implemented a renaming feature that allows the user to rename a device, and then that device friendly name is what we call it, is saved and is being able to be loaded anytime you stop and restart the program, unplug or replug the device, anything like that. Then device configuration, mentioned earlier that you could load in the settings for oscilloscopes before an experiment, and that is done. Los Alamos actually has a text file that they have all the names and then all the settings of a device. So as I spoke about earlier, those friendly names, they have that friendly name at the top, and then they have all the settings they want to configure for the device, and they do that for every single device they're using for the experiment. And then all it takes is one push of a button to push all those settings out to whatever connected devices there are for that experiment. And then, of course, we have arming and triggering the device. So all you have to do is press one button, and it arms all of the scopes that are connected for the experiment. And then kind of that workflow earlier, as soon as any of the scopes get any sort of trigger of data, then they're all triggered, and then you can save the data. And then logging and error display is mainly for us as developers. We're able to track any issues, any bugs, and Los Alamos actually really liked that implementation, just in case they had to go in and find out if anything happened, if anything went wrong during an experiment. And this is also very useful for future developers. And then, of course, data collection. The main data format that Los Alamos really wanted us to implement was their NumDAT, and that is their personalized data format that we were able to implement through weeks and weeks of making sure that the format is in the correct format. And we also have a simple format, CSV, and we're able to add on for future teams more and more and more.
Yeah, and then going into just some of the impact of our project, obviously this will be directly used by Los Alamos for their experiments. And one of the biggest reasons why they wanted this is just for increased efficiency. It helps a lot with that manual configuration and pushing of buttons and adjusting settings. They're able to do that directly through our program, just in one go without having to, spread their efforts. And this just makes it a lot easier and more memory intensive, or less memory intensive, for them to use. And then the second is just the maintainability of our program. It's able to be continued to be updated by future teams. They can expand upon it and add more features if they desire, or continue to improve what we already have. But it's also backwards compatible with the instruments that they already have and that they've been using. And just for some ethical considerations, all the data is accurately saved and received. And from the experiments, it's able to save directly from the scope to the computer with no problem in that transfer. And then for security, it's all on the local device. There should be nothing crossing over the network that can be attacked or accessed by other people. So our program is very secure and easy to use.
Yeah, and then I can give a quick hands-on demo. So if you look here on next to us, we have an MSO46 oscilloscope and also delay generator on the other side. So I can give a quick demo of our program. So yeah, this is our simple user interface. And as you can see, we have just that one MSO46 oscilloscope connected right now. It's connected via USB. And if I were to unplug it, so I have a plug here, it would disappear. And then when I plug it back in, it will automatically detect and show up. And then like we said earlier, we can rename it to a friendly name. So this is, device number 12. We can, save it as that. And then yeah, for some of the functionality, we'll be able to select it and we can automatically arm the device. And what will happen when I arm it is it'll turn the oscilloscope into single sequence mode. And then the delay generator that we have will send a pulse and it'll trigger the scope and then we'll get in a triggered state. So once I select this, I'll be able to arm it and then it'll automatically trigger with some data. And from there, I'll be able to either save the data or I can just go back. So if I were to save the data, I can browse in a file and find a random folder to I want to save it. And as you can see, our data is organized by the day. And if you haven't saved any data that day yet, it'll automatically create a new folder to be able to visualize it a little bit better. So as you can see, we also have NumDAT format and a CSV format. So since we got that data from the triggered state, we're able to save it directly from here, and it'll save it just like that. And we're also able to arm it, trigger it, and save it from this screen as well. So yeah, we're also able to save it in a CSV format, which I can show right here. It'll save as a CSV. Yeah, and then lastly, we're able to load configuration files straight to the scopes. So if I go here, we're able to select a example text file that Los Alamos sent us, which just has some simple text instructions on how to set up the scope. And it'll give a little summary when we input it there, and we can load it, and you won't be able to see it, but I'll move it a little bit. But the scope is oh yeah, it's loading, but it's kind of hard to see. But yeah, so that's kind of our yeah, our user interface and how it interacts with the scope. And like I said earlier, if it's connected to, a bunch of different ones, it'll look kind of like it does down here, and you can select certain ones and disconnect certain ones and yeah, be able to you do them all at the same time and arm them all at the same time and save data from them all at the same time. But yeah, that is our project. Thank you for listening.
Thank you.